So in this problem, we're given mid-segments, congruent parts, and we're asked to prove that we have a rhombus. I do want to point out that there is definitely more than one way you can approach this. I'm just showing you one way to do this, and I'm going to focus mostly on that segment addition postulate. So we'll start with our statements and our reasons. And number one, I'm going to go ahead and write it all. Vx and Zx, segments Vx and Zx, are mid-segments of triangle TWY, and then we have TW is congruent to TY. Oops, number one, given. Now, I'm going to go ahead and take this statement right away and change that to say that their measures are the same. That is the definition of congruent segments, because I want to use that segment addition postulate in this, and I'm going to need to work with their measures. So number three, what I want to point out here on number three is that we have TV would be the same length as VW, and TZ would be the same length as ZY. Now, why am I allowed to say that this is going to be congruent to this and this is going to be congruent to this? Well, the reason is that when you have a mid-segment divides another segment by its midpoint, and when we have that, we got congruent parts. Number four, let's go ahead and bring in that segment addition postulate then. This plus this makes the larger TW. So TV plus VW gives me the larger TW. And let's do it for this segment as well. TZ plus CY is going to give me the larger TY. That is called segment addition postulate. Now, since I have these pieces up here, notice that these two are the same. So these two are the same. So I can set this equal to this. And then what that gives me is TV plus VW is equal to TZ plus ZY when I set them equal to each other. That's just substitution. But the other thing I can substitute in is, since I know that TV and VW are the same, I could replace this with TV. So now for number 6, I have TV plus TV equals, and then look over here, TZ and ZY are the same, so I can replace ZY, so I can have TZ plus TZ. That again would be substitution. Now let's simplify this. How many TVs do I have? 2 of them. How many TZs? 2 of them. So that's just simplify. Now if I divide both sides by 2, then I have TV equals TZ. So that is just the division property. So now let's go back to the figure and look at what we have. We now know that TV and TZ are the same. We've got 2 of our sides. We just need to prove these are congruent as well. So let's keep going and looking at what else we can do. One of the things that we know about a mid-segment is that this mid-segment is going to be half of the length of the larger side. So let's go ahead and work with that. 1/2 of TY is going to equal that VX. And in the same accord, let's look at this one here. ZX, 1/2 of TW is going to give me ZX. So 1/2 of TW is going to give me ZX. And the reason is that a mid-segment is half the length of its corresponding side. So now we can go right back up to here before, like we had. We can say from up here, we know we have TY. What was TY made from? TY was made from this, TZ plus ZY, which, remember, we said was 2 of these, because this is TZ, and then remember we substituted here before and put that as TZ. And then we also did the same here. So let's go ahead and take that. So TY is 2 of these TZs. So 1/2 times that TY, which was 2 of the TZs, and that equals VX. Let's do the same thing here. 1/2 of TW. Look at TW. Remember how we said before TV plus TV because we replaced this with TV? That was 2 TVs. So I'm going to do 2 TVs, and that's going to equal ZX. So again, all I did was substitution. But if we clean this up, look at what happens. 1/2 of this with 2 cancels, leaving me with TZ equals VX. And if I do half of 2, that's going to cancel, leaving me with TV equals ZX. And what that was us just simplifying. Now if you look, TZ and VX are the same. So if this has 1 mark, so does this. And then TV and ZX are the same. So that's 1 mark. So look at that. Now all 4 sides are congruent. So number 12, we can now say that TV is equal to TZ, which is equal to ZX, which is equal to VX. And the reason is substitution again. Sorry, I'm getting down off the paper. And if that's true, then that means that segment TV is congruent to segment TZ, which is congruent to segment ZX, which is congruent to segment VX. And the reason is definition of congruent segments. And now finally, 14, we could say TVXZ is a rhombus. Why? Because all 4 sides are congruent. Now, one of the other things that you could have done is you could have looked at like the angles, because remember when you have mid-segments, they make parallel lines, and you could go into exploring about how you could use maybe the angles to complete this proof as well.